It's my absolute pleasure to welcome and introduce Sanjive Agarwala. He is the Corporate Vice President and General Manager, IP Group, since February 2021 and running the division since 2019. His responsibilities include analog memory interface and Tensilica processor IP system solutions, with a focus on expanding the Cadence IP portfolio and enabling customers to get their system on chip products to market faster and with higher quality. Prior to Cadence, Sanjeev was at Texas Instruments, where he led the development of the company's digital signal processing, artificial intelligence, and digital analog platform technology, as well as high-end SoCs targeting automotive, industrial, and wireless base station applications. Welcome, Sanjeev.
Hello everyone, I'm excited to be here to share our perspective on semiconductor industry and how it is transforming our lives. Our industry has made significant impact over the last 3+ decades, and even a greater transformative effect is unfolding right ahead of us. It is a great time for our children to be in this space in the electronics industry, which is in a secular growth trend for a while. The semiconductor and pandemic is almost like we believe has been a perfect storm and a greatest experiment overall. If we look at how the world moved online, where it began to work, educate our children, play, shop, entertain ourselves, it has brought a whole new perspective on our industry and its impact on the economy and our lives. Nothing has demonstrated more clearly than the recent silicon chip shortage and how much the pervasiveness of it is in everything we do. The global semi sales in 2020 were about 450 billion. They went up to 525 billion in 21 and are expected to continue to grow double digit for a long time. One of the fundamental things we all can see is the sheer amount of capital expenditure and investments going towards expanding the silicon manufacturing footprint around the globe. So if you look at the overall big picture, what I want to kind of share with you all is really how the silicon is changing our lives and really what are the fundamental facets about it. We'll talk about the three key aspects. One is the global trends driving the sheer ramp, which we are seeing more so now than before. And then what are the disrupting aspects impacting those trends, and then finally what are the enabling technologies which are fueling this growth. So overall, if you look at these three pillars, it gives us an overall greater perspective and understanding of what is happening and where are we going. If you look at the silicon requirements over time and how really we have evolved, over the last 3 decades we started from a PC era to smartphone and then over internet proliferating our usage. But that has also started to transform over last decade and it has gone in a hyperdrive mode. The way amount of data we are generating, processing and consuming is evolving. And beyond the typical primary drivers around basically entertainment, shopping and a human-centric, there's a lot of machine-centric aspect in terms of the various industries which are starting to have a greater impact in terms of their semiconductor usage and the value they offer. They span from clearly healthcare, around industrial automation, autonomous driving that just doesn't apply to our cars, but the entire transportation industry, the online collaboration, and in general the advent of machines which are connected to the internet for much more value we can derive out of it. So the overall dependency on silicon is starting to grow phenomenally across the globe. And all these things put together really are driving a huge resurgence and demands of the silicon industry. The three key disruptors which are enabling also this demand and really becoming the core foundation pillars are the cloud, which is becoming omnipresent and always available, the edge processing, where typically we had human-centric devices, but now we're going to a machine-centric era where everything around our lives, visible and invisible, is starting to get connected for much more value-added services. And then finally, the communication medium, where we have come up with a much more efficient way of moving data around between the cloud and the devices and being able to manage the explosive growth of data as we see. And then as we look at the enabling technologies which are fueling those disruptors, it's fundamentally around cloud. It has to do with the disaggregation, which I'll talk about more a little bit. And in communications, 5G has had a transformative effect, and it is just starting to take shape as we look into the future. And then finally, on the edge, the sensor processing with embedded AI, and more importantly, integrated sensors, which are driving the massive proliferation and usage across every aspect we can think of. So we look at this whole aspect of these three pillars and what is driving them, and then finally how we all technologists are enabling to make this happen. So let's first take a quick look at the cloud and how cloud is evolving from where it has been traditionally to where we are going. So the fundamentally cloud is moving from generic servers to much more optimized workload specific servers. And whether we look at our compute, whether we look at storage, or basically the usage of this cloud, it's becoming much more content specific. Traditionally, the servers have been more about putting big chips together and making the servers, from an innovation point of view, they were moving much slower every few years. Now, in the new architecture of the cloud, as we look at it, the compute, the memory, and the I/O has been disaggregated, and it is becoming much more workload specific, driving the needs of the particular target applications, like whether you're going after web servers, or you're going after banking, you're going after analytics, or defense, and so forth, and to be able to produce much more cost, power, optimized, and being able to handle lot larger workloads. And the fundamental enabling technologies which have really led to this hyper growth have to do with one is the fundamental architecture of the processors, where in terms of being able to put not just single cores but multi-cores and more workload specific processors is becoming a big really enabler. The other has to do with the interconnects, whether we look at the coherent interconnects like CXL, or what we look at what we call the data superhighways in terms of SerDes technologies, etc., where traditionally we were talking 28, 56 gig, and today we talk 112 and going to 224, offering terabits of performance in terms of moving data around. And then similarly, in terms of really the EDA and the CMOS scaling enhancements, where we are able to put lot larger, lot more complex devices with relatively modest teams, achieving our cost performance and area targets, etc. And then finally, this 3D IC technology, where we are able to build a lot more advanced systems in package. A great example of this is the recent Graviton 3 announcement from AWS, where about a month ago, where they talk about how they have been able to put their next generation server platform using 3D IC technology and broken down into discrete pieces of silicon which are highly differentiated and value added. Similarly, if we look at from an edge point of view, how the trends are evolving, first I'll talk about AI, and then I'll get into which is having a very transformative effect, and then I'll also talk about in general the integrated CMOS sensor. So traditionally, AI up to now has been primarily deployed in the cloud today. And that we see evolving dramatically, where cloud AI is moving not just in the cloud, but also onto the edge and on device. And this has also a very transformative effect, because the amount of data which is being generated at the edge, if we have to transport all that data to the cloud, process, infer, and then bring it back, we tend to really not get the full advantage of the solutions we are going after. So overall, what we believe that about till 2021, 20% of the data was processed at the edge in terms of AI function, and majority was in the cloud. By 2030, we believe it'll almost flip, where about 80% of the data will be inferred at the edge, and about 20% will be in the cloud. So the quantity of data we are able to manage, navigate, and infer will dramatically go up at the edge, and that has to do with, again, the capability we can put in our sensors as we go forward. So traditionally, on the edge side, we have looked at the sensors as more from a sensor data processing. They were, so to speak, smart, but not necessarily intelligent. And now we are going towards a model where we not only have the sensor data processing, but we are going to integrate inferencing and decision making in a similar cost and power footprint. The other fundamental transformative effect also has been to do with the CMOS sensors themselves. A good example of that is millimeter wave. Traditionally, the radar front end was done on a separate chip in technologies like SiGe. With the advent of the 77 gigahertz CMOS radar sensors, which are very cost optimized and integrated in the same technology as our digital logic, and on top of that, we are able to now integrate flash and MRAM memory technologies and all, and finally couple that with domain-specific compute to be able to optimize the overall performance and cost point. We are able to put all these technologies into an integrated solution to build this class of sensors or sensor at the edge, which have all the functions integrated and being able to offer the performance and cost we are looking for. So this has a very fundamental transformative effect, where now we can think of putting sensors in everything we do, in terms of our factories, in terms of our cars, in terms of our homes, in terms of every aspect of life. Now we are able to proliferate the sensors and their applications. If you look at from the communication point of view and how 5G is fundamentally changing, being able to move all this data I was talking about between the cloud and the edge. Overall, 5G is definitely revolutionizing the communications pipeline compared to 3G, 4G in the past. And the fundamental premise of that has to do with a distributed architecture, which is at a very high level. We think in terms of three core pillars, which is around the core, the regional, and the edge. And it comes down to all in terms of being able to handle the massive amount of bandwidth requirements in the world we are going, and being able to effectively manage the latency. So with this software-defined radio coupled with this three-pillar architecture, what we are able to do is optimize the bandwidth and latency and quality of service across all these three pillars to overall optimize and continuously prioritize to get the right quality of service across all the pillars. And therefore, in 5G architecture, in terms of really at the edge, where, for example, if cars are trying to do or machines are trying to do real-time communication, we are able to manage things like short packets and latency to hit the right real-time response, as well as being able to attach not just millions of devices, but billions of devices to get the right communication medium. Similarly, in the regional, we are able to build a distributed architecture to be able to span our coverage, and then finally at the cloud, being able to offer the scale and the capacity to serve as the backbone for both regional and the edge. And here also, if you look at why 5G is so different, it really comes down to the enablers, which are the fundamental distributed architecture, software-defined radio, being able to manage latency, concepts like short packet, etc., which we are able to really leverage in this overall architecture. And then analog and RF have played a huge role in terms of being able to build very high-performance DAC ADC RF front ends to be able to handle this massive MIMO and beamforming applications. And similarly, the advancements in our analog technologies, coupled with finally our 3D IC, to be able to put these 5G systems together. So overall, the foundational elements, again back to the CMOS advancements, the 3D IC, the analog architectures, the RF, integration of flash CMOS, all of these are becoming core pillars to be fueling these disruptors and the three enablers in terms of the overall, in terms of cloud, the comms, and the edge. So with that backdrop, if we really take a bigger picture look, how pandemic has really unleashed a new perspective of how we look at things. Imagine till 2 years ago, probably one of my favorite thing which has just impressed me has to do with the vaccine development. Traditionally, what would have taken 5 to 7 years, the world has achieved that miracle in less than a year. And more importantly, the mRNA technology is so game-changing, fundamental, where going forward, the implications of it in terms of targeted drugs for targeted applications just opens whole new way of looking at drugs and healthcare. And this has been enabled, again, if you look at fundamentally by the semiconductor technology at the core, being able to offer the compute power, the analytical capabilities, the AI aspects to be able to do the drug research, development, and productize it in such a short time. And then similarly, the whole, what I call the greatest experiment of work from home of the entire world, not just certain targeted population, has been a tremendous success, so to speak, by how collaboratively the world has been able to work, it has been able to play, it has been able to entertain and move forward. And all of this has been put in perspective and in hyperdrive by the, again, unfurling of the silicon renaissance, which we are able to leverage across all these platforms. So if we look at really how we look at things as we go forward in this, basically from the overall disruptors and the trends to the enabling technologies, it is fundamentally transforming how we are going to live, work, and play to a whole next level. And I think I'd like to share with you a few of my perspectives, when we look at future. Imagine you can form an orchestra across the globe where musicians sitting in different countries on different parts of the planet can form a concert together, put music together in real time, and have a concert-like effect. This could have been almost impractical, but now where we are heading, this is very feasible. And imagine the new genres of music, the new diverse ideas people can bring to really come up with new music or new really arts which were not possible till recent past. Similarly, when we look at autonomous vehicles, but I kind of tend to broaden that more. It's not just about autonomous vehicles, it's about autonomous transportation, whether it's on the road, whether it's our trucking industry, whether it's in the ocean, and potentially even in the air. That is going to fundamentally change how we look at transportation of moving people or goods or services as we go forward. Similarly, augmented reality. Instead of doing like a Google search to figure out where do you want to go or a restaurant you want to find, imagine all that coming much more intuitively to you as you are normally walking around leading your daily lives. And similarly, if you look at the virtual reality, what's about to unfold ahead of us, this could be put to a lot of good uses, whether it's around doing a remote surgery or having much more collaborative online education classes or problem solving across different regions, and people can come together to have much more effectively virtual collaboration. Similarly, our homes. What I see in the future is going from smart homes to what I call intelligent homes, which are much more sensitive to your needs, much more adaptive, and much more efficient in terms of really how you go about living your daily lives. And then similarly, security and surveillance, how we look at our safety of our families, our children, and our workplaces. It's going to continue to evolve where there's a significant implications how this technology can make it much easier, intuitive, and valuable as we move forward. And similarly, the implications of drones, whether it's for deliveries or emergency response, or being able to go in places where, like in fires or other places where traditionally it's very hard to provide emergency services at a human being level, these machines will be able to really bring a whole new value chain overall. And in our industries, our factories, they are already evolving, but that is going to into a hyperspace with a 4.0 industrial in terms of the factory automation, building automation, machine automation, whether your machine has sensors built in to detect vibration and prevent downtime by advance notice of machine repairs, all the industrial factory floor communication to improve the efficiency of factory, throughput of factories, the whole IoT implications of industrial IoT implications in really taking our factories to the next level, I think that is just unfolding as we speak. And then finally, I believe drug research in general will have a fundamental transformative effect as to where we are heading. So overall, silicon is enabling a ubiquitous hyperconnectivity and being able to have these cost power functions which are highly optimized for targeted applications, where we are taking the world not just having the semiconductor or the electronics more centered around human, but more around machines and being everywhere in everything we touch and feel and do. So overall, our lives are fundamentally going to transform as we speak, as we go forward, and there is abundance of opportunities to innovate, make an impact as we go forward. I believe the best is yet to come. Thank you.